This is part 3 of a 3-part series on the Cayley-Purser encryption algorithm, encryption and decryption procedures. When we last left off, Bob had finished generating the public key consisting of the values of n, alpha, beta, and gamma, and the private key consisting of the value of chi. He had published the public key for Alice to use to encrypt a secret message of her choosing to send to Bob. We now turn to Alice to see how she encrypts her secret message using nothing more than the values of n, alpha, beta, and gamma. Upon receiving these public key values from Bob, Alice will first generate a random natural number s and compute the following. Gamma to the s power, which is expressed as the value delta. Delta inverse times alpha times delta, which is expressed as the value epsilon, and delta inverse times beta times delta, which is expressed as the value kappa. Next, Alice will decide on the message she wants to send to Bob, convert her message blocks into numbers, and place them 4 at a time as elements in the 2x2 matrix mu. So for example, if Alice would like to send the message hi hi to Bob, she could convert hi hi into 8989, since H is the 8th letter of the alphabet and I is the 9th. Her 2x2 matrix mu would then look something like this. To encrypt the matrix mu, Alice will evaluate kappa times mu times kappa, the result of which is the encrypted matrix mu prime. Finally, Alice will send mu prime her encrypted matrix and epsilon to Bob for him to decrypt. Upon receiving epsilon and mu prime from Alice, Bob will now compute chi inverse times epsilon times chi, which results in gamma. Remember that Bob has access to the value of chi because he retained possession of the private key, which consisted of the value of chi. A slight correction here. Chi inverse times epsilon times chi is actually denoted as the value of lambda instead of gamma. Bob's second and final step is to evaluate lambda times mu prime times lambda. If all has gone according to plan, the result of this expression will be the original plaintext mu matrix. In other words, the 8989 matrix. So as I said before, the Cayley-Purser encryption algorithm has since been found to be a flawed method of public key cryptography. But hopefully you can now see the simple elegance and brilliance of this particular crypto system and have come to appreciate it and its creator a bit more. I hope this was helpful and thank you for listening.